Welcome to the Deep Dive, where we plunge into the most fascinating and impactful stories shaping our world. Today, we're tackling a question that truly feels like it's been plucked from the pages of, well, some cutting-edge science fiction novel. What if a computer could solve some of the world's most incredibly difficult math problems, not merely with brute force calculation, but with something, astonishingly akin to creative thought? It's a captivating and, frankly, paradigm-shifting idea, isn't it? And that idea isn't science fiction anymore. Not really. Today, we're embarking on a deep dive into an extraordinary achievement from Google DeepMind's Gemini, specifically its groundbreaking Deep Think mode. Our mission is to unpack how this advanced AI recently achieved a gold medal standard at the International Mathematical Olympiad, the IMO. We want to explore what this truly signifies for the very nature of AI's reasoning capabilities, and critically, how this breakthrough could ripple out. How it could impact everything from accelerating scientific discovery to fundamentally changing how you approach complex problem solving in your own life and work. We've pulled from a rich stack of sources for this deep dive, including recent, highly detailed reports directly from Google DeepMind. These offer some unparalleled insights into this specific IMO achievement, the exciting global rollout of DeepThink, and some broader strategic updates from their recent Google I/O conference. It's more than just a tech announcement. It feels like a profound moment. Okay, let's truly unpack this. The International Mathematical Olympiad, it's long considered the ultimate intellectual crucible for the brightest young human minds, right? And it has now seen an AI system not just compete, but genuinely excel at an elite human equivalent level. It's truly a staggering leap in what we thought AI was capable of.
Indeed, it really is. And what's absolutely fascinating here, I think, is not just that it solved these incredibly hard problems, but how it accomplished it. This isn't about raw computational speed or just, crunching numbers faster than a human. It signals a monumental evolution in AI's capacity for complex, abstract reasoning. It's propelling it significantly closer to a form of flexible, intuitive intelligence that we previously associated almost exclusively with human cognition. It's a fundamental shift in how AI thinks, if you will.
Right. To truly grasp the enormity of this achievement, we first need to set the stage. We need to understand the International Mathematical Olympiad itself. For those who might not be intimately familiar, the IMO has been held annually since 1959, and it stands, without a shadow of a doubt, as the world's most prestigious and, frankly, intellectually demanding competition for pre-university mathematicians. It's a global arena where the brightest young minds representing their respective countries convene to showcase their raw, advanced problem-solving talent. We're talking about the absolute zenith of high school-level mathematics, pushing the boundaries of what even, prodigies can achieve.
That's the crucial point, a really crucial point. And to fully appreciate the profound challenge involved, you need to consider the intricate nature of the IMO problems. Each contestant faces 6 exceptionally difficult problems. They're meticulously chosen from distinct, often intertwined branches of mathematics: algebra, combinatorics, geometry, number theory. These are not problems you can solve by simply memorizing formulas or applying standard rote algorithms. Not at all. On the contrary, they demand deep, intuitive understanding, often requiring creative leaps, truly novel insights, and the profound ability to connect seemingly disparate mathematical concepts in non-obvious ways. It's less about calculation, much less, and far more about ingenuity, profound logical insight, and elegant problem formulation. The competition's rigor is legendary. Medals are awarded only to the top half of the contestants, maybe even less sometimes. And even within that highly elite group, typically only about 8% receive the highly coveted gold medal. This context is absolutely critical for truly appreciating the magnitude of what Google DeepMind's AI has accomplished. For decades, this competition has served as a benchmark for exceptional human intellect. And now, it stands as a testament to the advanced capabilities of AI.
Knowing that, it makes perfect sense then, almost inevitable, that the IMO has long been considered an aspirational challenge for AI systems. It represents a genuine, undeniable, and publicly verifiable test of their advanced mathematical problem-solving and abstract reasoning capabilities, far surpassing what even the most sophisticated calculators or, traditional computational software could manage just a few short years ago. In the world of pure mathematics, for AI, it's kind of like conquering Everest, isn't it?
Absolutely, precisely. And to fully appreciate the progression, the journey, it's essential to look back at last year's attempt, at the IMO 2024. Google DeepMind's combined AlphaProof and AlphaGeometry 2 systems achieved what was at the time considered a truly remarkable silver medal standard. They managed to successfully solve 4 out of the 6 problems, earning a total of 28 points. At that juncture, this was unequivocally a breakthrough. It demonstrated that AI was indeed beginning to approach elite human mathematical reasoning, a feat many thought was still years, maybe even decades away. However, it's vital to highlight the significant limitations inherent in those earlier systems.
Okay, like what specifically?
Well, for one, those 2024 systems still required substantial human intervention. A lot of it. Human experts first had to meticulously translate the problems from natural language, the way you or I would naturally read and understand them, into formal languages. A prominent example is Lean, which is a powerful interactive theorem prover. These formal languages are incredibly precise, yes, but they're also extremely rigid and require deep expertise to use correctly. So the AI wasn't reading the original problem statement directly. It was working with a human-translated formalized version. And then once the AI generated its proofs, those proofs also had to be translated back from the formal language into natural language for human understanding and verification.
Ah, okay, so not quite end-to-end AI problem solving then.
Not at all. This clearly indicated a significant human-in-the-loop requirement. The AI wasn't fully autonomous in its comprehension or explanation.
Got it. And you mentioned something else.
Yes. Another crucial detail that underscores the incredible efficiency improvements we're about to discuss is the computational cost. That 2024 attempt, achieving a silver medal, took 2 to 3 days of computation.
Days. Wow.
Days. So while it was a breakthrough then, it certainly wasn't operating in real time, nor was it fully autonomous in its language understanding and proof generation. It's a powerful co-processor, perhaps, but still dependent on human scaffolding.
Okay, so that sets the stage perfectly. Here's where it gets really interesting, because this year, with the advanced version of Gemini DeepThink, it's not just an improvement. It's, like you said, a whole new ballgame. The leap forward is truly astonishing, almost like going from, I don't know, a horse and buggy to a supersonic jet in a single generation.
Indeed, that's a good analogy. The breakthrough performance of Gemini DeepThink at IMO 2025 is quite simply unprecedented. This advanced model didn't just perform well, it solved a staggering 5 out of the 6 IMO problems perfectly. That's a feat that would challenge even the most seasoned human Olympiad veterans. This earned it a total of 35 points, a score that was been officially certified as a gold medal level performance. And importantly, the solutions themselves were made public, which speaks volumes about their rigor, their clarity, and their verifiability.
5 out of 6. Perfectly. That's incredible. But you said the how was key.
Exactly. But here's the truly crucial difference, the game changer that redefines the frontier of AI reasoning. Unlike its predecessors that needed human intermediaries in formal languages, this advanced Gemini model operated end-to-end in natural language.
End-to-end. So no human translation at all.
None. This means it took the official IMO problem descriptions, presented in plain, unadorned English, and directly produced rigorous, human-readable mathematical proofs from them. Without any human translation or intervention required at any stage of the problem-solving process, it understood the nuanced language of the problem and generated its own elegant solution directly. Even more impressively, it achieved this within the strict 4.5-hour competition time limit.
Wow, so real-time comparison to humans.
Exactly, putting it in direct real-time comparison with human competitors. It didn't need days of computation, it needed mere hours, just like a human participant.
And how were the solutions received? Did the experts find them?
Yeah, that's the other key piece. The validation from human experts is absolutely critical here. Professor Dr. Gregor Dolinar, the IMO president himself, confirmed the achievement. He stated, and I quote directly here because it's important, "We can confirm that Google DeepMind has reached the much-desired milestone, earning 35 out of a possible 42 points, a gold medal score." And he added, "Their solutions were astonishing in many respects. IMO graders found them to be clear, precise, and most of them easy to follow."
Astonishing. Easy to follow. That's high praise from the top.
Extremely high praise. This independent expert grading from the very highest authority in the field truly validates not just the correctness, but also the quality, the clarity, and the human interpretability of the AI's thought process. It wasn't just solving, it was explaining its solution in a way that resonated with human mathematical understanding.
That quote, coming directly from the president of the IMO, truly hammers home the significance. To go from a silver medal standard requiring days of computation and that painstaking manual translation into formal languages, to a gold medal standard achieved in real time, purely in natural language that's not just an incremental improvement, it's a profound paradigm shift. It almost sounds too good to be true, doesn't it? From your perspective, what do you think was the absolute biggest technical hurdle in achieving this specific leap, especially moving away from that formal language requirement? And how specifically did DeepThink overcome it?
That's an excellent, insightful question. Because you're right, the shift from formal languages to end-to-end natural language processing for proofs was indeed the Everest of this challenge. The biggest technical hurdle was truly bridging the gap between the ambiguity and nuance of human language and the absolute precision required for rigorous mathematical proof. Human language is inherently fuzzy, right? A single word can have multiple meanings. Context is everything. Mathematical proof, however, demands unwavering, unambiguous logic at every single step.
Yeah, that seems like a massive gap to bridge computationally.
It is. Previously, formal languages like Lean acted as a necessary intermediary because they stripped away that ambiguity, forcing the problem into a structure that AI could reliably process and reason within. The challenge was to empower the AI to perform that stripping away and subsequent structuring itself directly from natural language. DeepThink overcame this through a multi-pronged approach that hinges on its ability to internally model complex problem spaces. Firstly, its vastly improved natural language understanding doesn't just parse words, it attempts to infer the underlying mathematical intent and logical structure, even from subtly worded problems. Secondly, it uses its parallel thinking mode, which I think we should definitely dig into next, to explore multiple interpretations and solution paths concurrently. It's like it's self-correcting and refining its understanding as it goes. If one interpretation leads to a dead end, another might reveal the correct logical formulation.
Okay, so parallel thinking is key.
And thirdly, its extensive training on high-quality solutions in natural language has taught it not just mathematical concepts, but the style and rigor of human-readable proofs. This allows it to translate its internal, precise reasoning back into clear, coherent natural language steps. It's an internal linguistic and logical bridge building that was previously externalized to human experts.
That makes perfect sense. It's like it's internalized the human mathematician's ability to interpret, formalize, and then articulate their work. And that brings us right to the core of this breakthrough, DeepThink mode itself.
Okay, so let's really unpack DeepThink mode. You mentioned it's an enhanced reasoning mode for complex problems. What does that mean in practical terms? Is it like giving Gemini an advanced brain-boosting strategy, a new, fundamentally different way of approaching problems? Exactly, you've hit on it precisely. Think of it as fundamentally changing how the AI processes and explores solutions. The core concept behind DeepThink is the implementation of what Google DeepMind calls parallel thinking techniques. Unlike a traditional AI, or even how many of us might instinctively approach a problem which often involves following a single linear chain of thought, trying one path, seeing if it works, and if not, backtracking and starting fresh. DeepThink operates differently. It operates by simultaneously exploring and combining multiple possible solutions before arriving at a final answer.
So it's not just trying one idea at a time, but many at once, like a simultaneous brainstorming session, but on a, well, superhuman scale.
Precisely. That's a great way to put it. To use an analogy that might resonate, imagine a top human mathematician or a brilliant puzzle solver grappling with an incredibly tough problem. They don't just pick one idea and pursue it blindly until it breaks, right? Instead, they might jot down several different approaches, try a few different angles, perhaps sketch out a geometrical transformation while simultaneously considering an algebraic reformulation. Often, the aha moment, that flash of true insight, comes from an unexpected connection or synthesis between these seemingly disparate lines of thought they've been pursuing in parallel.
Okay, I can picture that.
DeepThink does precisely this, but at a superhuman scale and speed. It's not merely faster, it's profoundly more expansive in its problem exploration. This parallel processing allows it to consider a vastly broader range of hypotheses and potential pathways, drastically increasing its chances of discovering those non-obvious creative leaps that are the hallmark of true ingenuity. This is particularly effective for problems that are inherently multifaceted, demand genuine insight, or don't have a straightforward linear solution path. It's a significant shift from the more traditional sequential processing that characterized earlier AI systems. It allows for a depth of exploration that was, frankly, previously unimaginable.
That's a fascinating, almost mind-bending capability. It's like it's given more thinking time, more avenues to pursue, just like we would when tackling a really tough puzzle or a complex creative challenge. But how did it get so good at this? What kind of training made this DeepThink mode possible and taught it this highly sophisticated parallel way of thinking?
Right, the training is key. The methods employed for DeepThink are quite sophisticated and truly highlight Google DeepMind's innovative approach to pushing AI capabilities. Firstly, they leverage what are termed novel reinforcement learning techniques. Think of this like a meticulous, highly accelerated self-coaching process. The AI wasn't just shown correct answers and told to replicate patterns, it was given problems. And for every step it took in its reasoning process, whether it was trying a new hypothesis, attempting a specific proof strategy, or connecting two previously disparate mathematical concepts, it received granular feedback.
So it learns from trying and failing, essentially.
Exactly, but in a very guided way. Successful logical steps that led closer to a correct, elegant solution were rewarded, while less effective ones were implicitly penalized. Over countless iterations across a vast problem set, this reward system essentially taught DeepThink not just what to think, but how to think strategically and effectively through complex multi-step reasoning, even for abstract theorem proving. It literally learned the process of discovery.
That's amazing. What else went into the training?
Secondly, it was provided access to an incredibly rich and curated corpus of high-quality solutions to mathematics problems. This wasn't just random data. It was like giving the AI access to the definitive library of mathematical genius, the most elegant proofs from history, the clearest explanations, the most insightful solutions from master mathematicians. It literally learned from the best examples of human mathematical ingenuity, absorbing patterns of reasoning and proof construction that are considered exemplary. And perhaps most intriguing, the training even included general hints and tips on how to approach IMO problems and its initial instructions.
Hints and tips, like a cheat sheet.
Not quite a cheat sheet, more like strategic guidance. This wasn't just about raw data or pure reinforcement. It was like giving it the metacognitive strategies a seasoned human coach might impart, teaching it how to approach problem solving from a high-level strategic perspective, equipping it with a kind of intellectual heuristic.
That's a truly fascinating detail, including those general hints and tips. My mind immediately jumps to a human coach working with an athlete or a mentor guiding a student. How specific were these hints? Were they high-level strategic principles or more like detailed heuristics for certain problem types? And how does an AI process hints differently than it does raw data or even the reinforcement learning signals?
That's a very insightful distinction. The sources suggest these hints were indeed more akin to high-level strategic principles rather than specific step-by-step instructions. For instance, they might include meta-strategies like try to find a symmetry in the problem, or consider breaking down the problem into smaller, more manageable subproblems, or explore different representations of the mathematical objects. These are the kinds of abstract guidelines that human mathematicians learn over years of practice.
Okay, so strategic advice.
Exactly. The way an AI processes these hints is distinct from raw data. Raw data is what it learns from. Reinforcement learning teaches it how to learn and optimize its process. Hints, on the other hand, provide an initial framing or bias for its exploration. They act as guiding principles that inform the AI's internal search process, helping it prioritize certain lines of inquiry or types of transformations before it even starts its deep parallel exploration. It's like giving it a set of excellent conceptual tools before it delves into the specifics of a problem, helping it narrow down the infinite possibilities into more promising avenues for its thinking time. The strategic guidance is what nudges it towards more intuitive or human-like problem-solving approaches rather than just, brute forcing everything.
So this parallel thinking strategy, the reinforcement learning, the curated data, the strategic hints, how does all of that marry with the idea of extending the inference time you mentioned earlier? Is it like giving DeepThink the luxury of a long, undisturbed contemplation, similar to how a human might spend days wrestling with a single profound problem?
Exactly. It's directly connected, and it's absolutely crucial. Extending the inference time, or what we can simply think of as giving Gemini more dedicated thinking time, isn't just about being slower. It's fundamental to DeepThink's effectiveness. While the version of DeepThink optimized for the Gemini app is faster for daily use, the gold medal IMO model, for instance, explicitly took hours to reason about these incredibly complex problems, intentionally matching the time constraints of a human competition.
So the time is necessary for the parallel processing to work.
Precisely. This extended time isn't wasted. It's the crucible within which DeepThink's parallel thinking capabilities truly flourish. It gives the AI the luxury of meticulously exploring a diverse range of hypotheses, pursuing multiple chains of reasoning simultaneously, evaluating myriad potential solutions, and continually refining its internal models until it arrives at not just a correct, but often a highly creative and robust solution. The novel reinforcement learning techniques we just discussed are specifically designed to encourage and reward these extended multi-step reasoning paths, effectively making DeepThink a more intuitive problem solver by enabling it to delve deeper and explore more widely than any previous model. It's less about raw computational speed in a single burst, and more about thorough, expansive, and iterative exploration of the problem space. Much like a human mathematician might spend hours wrestling with a single profound proof, letting their intuition guide their logical steps as they construct the solution piece by piece. This thinking time is where the magic of deep think truly happens.
Okay, that makes a lot of sense. So this isn't just about math competitions, right? This deep think power with its parallel reasoning and capacity for strategic intuition. It sounds like it has implications far beyond the Olympiad. Where else can this new way of AI thinking be applied? Where do you see it making the biggest, most tangible impact for you as a listener, regardless of your field?
You're absolutely right. The implications extend far beyond the realm of competitive mathematics. This capability for creative problem solving is incredibly potent and can be applied across a wide variety of domains, particularly those where problems are complex, multi-layered, and require more than just a direct, single-path solution. We're talking about scenarios that truly benefit from deep, nuanced reasoning.
Like what, for example?
Well, for instance, consider iterative development and design. The sources highlight DeepThink's impressive performance on tasks that require building complex things piece by piece, where the interaction of components is critical. A specific and highly relevant example given is how DeepThink can significantly improve both the aesthetics and functionality of web development tasks.
Aesthetics. That's interesting. So not just code, but design.
Exactly. Think about that for a moment. It's not just about writing correct, bug-free code. It's about making design choices that are intuitively pleasing to the eye and inherently intuitive for the user. Imagine you're a web developer or a designer, and you need to optimize the layout of an e-commerce page or the user flow of a complex application. DeepThink could analyze countless permutations of design elements, UI components, and underlying code, not just for technical correctness, but to suggest solutions that are demonstrably more appealing and functional based on vast data, helping you build more engaging and efficient digital experiences. This capability crosses into a more subjective creative domain, moving beyond purely logical functions.
Okay, web design is one area. What else?
Then there's the monumental potential in scientific and mathematical discovery itself. DeepThink's ability to reason through highly complex, abstract problems makes it an incredibly powerful and potentially indispensable tool for researchers across all scientific disciplines. Imagine its potential to help formulate and explore entirely new mathematical conjectures that have eluded human minds for decades. Or consider its capacity to reason through vast, interconnected bodies of scientific literature, perhaps thousands of research papers on a complex biological pathway or a new material science discovery. It could identify subtle patterns, connect dots that human minds might miss due to sheer volume of information or cognitive biases, and potentially even suggest novel experimental designs or hypotheses. For you, if you're a researcher, a scientist, an engineer, or simply someone deeply interested in the advancement of human knowledge, this could mean an AI partner capable of helping you push the very boundaries of what's currently known, accelerating the path to groundbreaking discoveries in fields from medicine to astrophysics.
Wow, a genuine research partner. That's huge.
It is. And finally, algorithmic development and code. DeepThink particularly excels at what are considered the grand challenges of coding, the kind of problems you see in elite programming competitions or foundational software engineering. These aren't about remembering syntax, they're about ingenuity in designing efficient, robust algorithms. We're talking about situations where problem formulation and careful consideration of trade-offs and time complexity is paramount. For example, if you're building a system that needs to process billions of transactions per second or run on a device with extremely limited battery life, DeepThink doesn't just write functional code. You can explore thousands of algorithmic variations, evaluate their efficiency across various parameters, predict their performance bottlenecks, and even suggest novel data structures, all to ensure the final code is not just correct, but incredibly performant, robust, and scalable. This capability moves beyond mere coding into the realm of true algorithmic artistry, helping you build more powerful and optimized software.
That's incredibly broad and truly impactful, spanning from creative design to fundamental scientific breakthroughs. But how do we know it's not just good at the IMO, which is, a very specific type of problem, but generally powerful and reliable across these incredibly different domains? Are there other robust ways to measure its capabilities beyond a single competition?
That's an excellent, critical question. And yes, the strength of DeepThink is indeed corroborated by its exceptional performance across a wide range of challenging benchmarks. These are specifically designed to test coding, science, general knowledge, and complex reasoning capabilities. This ensures it's not a one-trick pony, good only for mathematical proofs. For example, it leads the Web Dev Arena and L Arena leaderboards. These are particularly significant because they evaluate models based on human preference.
Human preference, but people actually like its output better.
Exactly. It means that real users consistently find DeepThink's outputs for web development tasks and general conversational responses to be superior and more helpful. This speaks directly to the practical, subjective quality, and utility of its solutions, not just technical correctness.
Okay, that's compelling. What other benchmarks?
It also achieves state-of-the-art performance across Live Code Bench v6, which is a benchmark specifically designed to measure competitive code performance. This means it can generate high-quality, efficient code for complex programming challenges often seen in professional coding competitions. Furthermore, DeepThink excels on humanity's last exam. This is a particularly challenging, multifaceted benchmark designed to measure expertise across diverse domains, science, advanced math, humanities, and more. It effectively tests a broad spectrum of high-level knowledge and reasoning. And for more direct mathematical comparison, it achieves a strong score on the 2025 USCI DOME, which is the United States of America Mathematical Olympiad, one of the hardest math benchmarks out there, second only to the IMO itself.
So it's acing tests across the board, basically.
Pretty much. And beyond pure logic and code, it scores an impressive 84.0% on MMMU, Massive Multitask Multimodal Understanding. This benchmark tests multimodal reasoning, showcasing its robust ability to process, interpret, and reason across different types of information, not just text, but potentially images, audio, and other modalities. This broader capability connects directly to Gemini 2.5 Pro's overall strength, which also learned and improved based on 5 principles of learning science, demonstrably outperforming other models in terms of educational effectiveness and robust generalization.
5 principles of learning science. What's that about?
It's about teaching the AI using methods derived from cognitive science on how humans learn best. Things like spaced repetition, retrieval practice, interleave learning. Essentially, teaching the AI how to learn more effectively, leading to more robust and generalized intelligence, not just memorization. So yes, this comprehensive suite of benchmark achievements unequivocally underscores that DeepThink is not just a niche mathematical genius, but a broadly capable, sophisticated, and versatile reasoning engine.
It sounds like DeepThink is a truly monumental step forward, not just in advanced mathematics, but in a wide array of complex problem-solving scenarios, impacting fields from pure science to practical software development, and even how you might interact with AI in the future. That brings us to a crucial point, though. As these models become more capable, more powerful, and more integrated into our lives, well, they also need to be built and deployed with robust safeguards. How is Google DeepMind approaching the incredibly important task of responsible development and deployment of DeepThink?
That's an absolutely critical consideration, and Google DeepMind has clearly articulated their unwavering commitment to build AI responsibly to benefit humanity. This isn't an afterthought or an add-on. Safety and responsibility are said to be meticulously built in throughout the entire training and deployment lifecycle of these models, from the initial data curation all the way through to how the model is used by end users. For instance, in their rigorous internal testing, Gemini 2.5 DeepThink demonstrated improved content safety and tone objectivity when compared directly to the standard Gemini 2.5 Pro model, meaning it's less likely to generate harmful or biased content and tends to maintain a more neutral, factual tone. They also transparently acknowledged a higher tendency to refuse benign requests, which indicates a deliberate trade-off. The model errs on the side of caution for safety, even if it sometimes means being overly conservative or declining a seemingly harmless prompt.
Okay, better safe than sorry, perhaps.
That seems to be the approach. And as AI's problem-solving abilities advance in complexity and reach into more sensitive domains, Google DeepMind is also engaging in what they call frontier safety evaluations. This means they're not just reacting to problems, they're proactively running highly sophisticated forward-looking tests to identify and assess entirely new risks that might emerge as AI models become exponentially more powerful. This includes planning mitigations for critical capability levels, meaning they're designing safeguards not just for today's AI, but for potential future AIs that could possess truly transformative or even dangerous capabilities. It's about thinking several steps ahead in safety, anticipating issues before they arise.
That sounds necessary. What about security, like hacking?
Yes, that's also a major focus. Furthermore, there have been significant increases in protections against indirect prompt injections. Think of this as a highly cunning form of cyber attack. Malicious instructions aren't directly given to the AI in an obvious way, but are subtly hidden or embedded within seemingly benign data the AI might process, perhaps in a website it browses, a document it summarizes, or a dataset it analyzes. This is a complex security challenge, and the work done here has made Gemini 2.5 the most secure model family to date, showcasing an intense and ongoing focus on cybersecurity aspects as well.
It's absolutely critical that as these models become more capable, they're also built with robust safeguards and a clear, explicit commitment to user safety and ethical deployment. That's reassuring to hear. So for many of our listeners, the big question right now is, when can you get your hands on this DeepThink power? How is Google DeepMind making this available, and what are the different ways to access it?
Right. The rollout strategy for DeepThink is multifaceted, aiming to balance broad access with responsible deployment and continued refinement. As of today, August 1st, 2025, DeepThink is rolling out directly in the Gemini app for Google AI Ultra subscribers.
Okay, so for Ultra subscribers first, how does it work in the app?
If you're a subscriber, you'll gain access to a fixed set of prompts daily where you can experiment with its advanced capabilities. You simply toggle DeepThink when you select the 2.5 Pro model in the prompt bar. Importantly, this version automatically integrates and works seamlessly with other helpful tools like code execution and Google Search. And it's designed to produce much longer, more detailed, and more richly reasoned responses than standard Gemini models.
Is this the same version that won the gold medal?
No, that's a very important distinction. The version available in the app for general subscribers is different from the one that achieved that specific gold medal at the IMO. The official gold medal version of the Gemini 2.5 DeepThink model, the one that can take hours to reason about complex math problems to achieve that elite performance, is being shared initially with a small, curated group of mathematicians and academics. This is for expert feedback, for them to kick the tires rigorously and to enhance their cutting-edge research. This allows for unparalleled testing and collaborative improvement within the academic and scientific communities.
Okay, so researchers get the top-tier model. What about developers or businesses?
Good question. For developers and enterprises looking to integrate this power into their own applications and workflows, DeepThink, both with and without integrated tools, will be released to trusted testers via the Gemini API in the coming weeks. This is aimed at better understanding its usability for a wider range of developer and enterprise use cases, ensuring it's robust and adaptable for real-world business and application development. So, to be clear about the difference for you as a listener, the app version you get today is designed to be faster and more usable day to day. And based on internal evaluations, it still achieves a bronze-level performance on the 2025 IMO benchmark, which is still incredibly capable for a wide range of daily tasks. But it's distinct from the full computationally intensive gold medal model that truly takes hours to tackle the most profound mathematical challenges.
Got it. So different versions for different needs. And it's not just DeepThink getting attention, right? You mentioned it's part of broader updates. What's truly exciting is that DeepThink isn't an isolated marvel. It's being integrated into a broader, rapidly evolving suite of advancements within Gemini 2.5, making these powerful AI capabilities even more accessible and versatile for you. From my perspective, what's the most surprising or unexpected capability you've seen emerge as these updates roll out that complements DeepThink?
That's a great question, because the ecosystem around DeepThink is just as compelling. One of the most surprising and, I think, potentially impactful capabilities I've seen emerge is the native audio output in the Live API. This is fundamentally creating much more natural and dynamic conversational AI experiences. Imagine this. With this capability, you could soon be discussing a complex mathematical conjecture or brainstorming a new scientific hypothesis directly with DeepThink, not just typing prompts. The model can now generate highly nuanced audio responses, allowing users to steer its tone, accent, and speaking style. You can literally tell it to use a dramatic voice for storytelling or a calm, reassuring tone for explaining complex concepts. This elevates interaction beyond simple text.
Talking to DeepThink, that's a big step up.
It really is. It also supports incredibly sophisticated features like effective dialogue, where the model detects emotion in your voice and responds appropriately. Or proactive audio, which allows it to intelligently ignore background conversations and know precisely when to interject with relevant information without being prompted. The Live API even incorporates DeepThink's underlying reasoning by allowing for explicit thinking capabilities to support more complex, multi-turn tasks, leveraging Gemini's core reasoning directly in a conversational flow.
So the AI is becoming a better listener and speaker.
In a sense, yes. And beyond pure conversation, they're also releasing new previews for text-to-speech in Gemini 2.5 Pro and 2.5 Flash with first-of-its-kind support for multiple speakers, meaning you can have two distinct voices speaking in a generated audio output. These text-to-speech capabilities are incredibly expressive, capturing subtle nuances like whispers, working across over 24 languages, and seamlessly switching between them within a single sentence. Then there's Project Mariner.
Mariner, what's that?
Project Mariner brings true computer use capabilities directly into the Gemini API and Vertex AI. This allows the AI to interact with software and systems, essentially giving Gemini the ability to navigate applications, click buttons, input data, and generally operate a computer environment much like a human, opening up immense automation possibilities for you in your workflows.
Wow, so it can actually use the computer for you.
Potentially, yes. And for developers, there are enhanced experience tools like thought summaries, which organize the model's raw, internal thinking process into clear, structured, human-readable formats. And thinking budgets, which give developers more granular control over cost by balancing latency and quality, even allowing them to turn deep thinking capabilities off if not needed for simpler tasks. It truly sounds like DeepThink is just one part of a comprehensive, integrated suite of AI advancements designed to make Gemini more powerful, versatile, and user-friendly for everyone.
It absolutely is. These updates collectively paint a vivid picture of a rapidly evolving AI ecosystem where advanced reasoning like DeepThink is being integrated into a broader, more practical, and increasingly innovative set of applications that could genuinely transform how we work, learn, and discover. So if we take a step back and look at the bigger picture, beyond the impressive technical specs and immediate applications, where do we go from here? What does a gold medal in advanced mathematics mean for the grander vision of AI and perhaps for the very future of human knowledge itself?
This is truly where DeepThink's achievement gains its most profound and far-reaching significance. While an IMO gold medal is a specific, albeit monumental milestone, Google DeepMind explicitly states that this is only at the start of AI's potential to contribute to mathematics. This is not an endpoint, it's a foundational step. The pursuit of teaching AI systems to reason more flexibly and intuitively, as DeepThink demonstrates with its parallel thinking and reinforced learning, is directly linked to the overarching ambitious goal of building AI that can solve more complex and advanced mathematics than ever before. We're talking about problems that might currently be intractable even for the brightest human minds, or those that require decades of focused effort.
So tackling the really big, unsolved mathematical questions.
Potentially, yes. There's a strong and growing belief that the ultimate future lies in combining strengths, the best of human ingenuity augmented by the best of AI capability. Agents that possess natural language fluency, the ability to understand and generate human language as naturally and powerfully as DeepThink demonstrated at the IMO, combined with rigorous reasoning, including verified reasoning in formal languages like those Alpha Geometry and AlphaProof excel at, and which are still being actively developed and refined, these will become invaluable tools. Who will benefit most profoundly from these tools? Mathematicians, certainly, whose work could be vastly accelerated, but also scientists across all disciplines, from physicists theorizing about the cosmos to biologists mapping complex protein interactions, engineers designing the next generation of infrastructure or computing systems, and researchers in every field grappling with vast data sets and complex problems.
So impacting almost every field of research and development.
Pretty much. These intelligent AI partners could help accelerate scientific discovery in unprecedented ways, design more efficient and sustainable systems, or unlock entirely new fields of inquiry that are currently beyond our grasp. Ultimately, the grander vision, as articulated by DeepMind, is that these advancements will help us advance human knowledge on the path to AGI, or artificial general intelligence. This isn't just about AI automating tasks, it's about building AI that can truly learn, adapt, and apply intelligence across a broad spectrum of tasks, much like a human, becoming a genuine intellectual collaborator in the grand human endeavor of discovery.
That's a powerful and deeply inspiring vision. This isn't just about AI doing our math for us or simply automating existing tasks. It's about AI becoming a genuine, transformative partner in pushing the very boundaries of what we can discover. It's about AI augmenting human intellect and creativity to solve problems that seem impossible today, transforming our quest for new knowledge from a solo human endeavor into a collaborative journey with artificial intelligence. We've covered a truly remarkable journey today, from Gemini DeepThink's unprecedented gold medal achievement at the International Mathematical Olympiad, a feat that reshapes our understanding of AI's abstract reasoning capabilities, to the fascinating technology of parallel thinking and novel reinforcement learning that powers it. We've explored its diverse and far-reaching applications that stretch from enhancing web development aesthetics to accelerating fundamental scientific discovery and optimizing complex algorithms. We've also delved into the critical commitment to responsible AI development, ensuring these powerful tools are built with robust safeguards to benefit humanity. And importantly, we've explored how you can start accessing some of this incredible technology today and what broader Gemini advancements are poised to revolutionize your interactions with AI. It's truly a remarkable moment in history, witnessing AI step into a domain of such profound and abstract human thought as advanced mathematics and perform at an elite gold medal level. It doesn't just challenge, it expands our very notions of what intelligence is and what machines are ultimately capable of.
Absolutely.
Yeah.
And this achievement, the mastery of intricate mathematical logic and creative problem solving by an AI, raises an incredibly important question for all of us. If AI can now master such profound intellectual challenges, what seemingly intractable problems in science, medicine, engineering, or even the subtle complexities of our daily lives might it help you unlock next?
That's a thought worth holding on to, worth mulling over. Think about how this emerging ability to deep think could apply not just to the most complex challenges you face in your work or your research, but even to the fundamental questions you're simply curious about. The frontier of AI is advancing at an incredible pace, and this deep dive into Gemini Deep Think shows us just how profound and personally impactful that transformation might be for all of us.
This was the Gist Podcast. If you liked it, please leave a like and subscribe to this channel.